all of the code in this video is available on github.com/opsdepartment. Hey everyone, today I'm going to show you how I set up multi-step tasks in Kubernetes using cron jobs and init containers. By understanding fundamental behaviors of Kubernetes and how it starts your pod, you can build extendable systems using nothing but just a little bit of YAML and some bash scripting. This is a model that I use in production workloads every day. It's proven to be very reliable. So let's just dive into it. There's a couple prerequisites that I've found really help this to be successful. The first of those is, as you see on line 8, we have the suspend value set to true. This makes sure that Kubernetes never executes this based on the schedule that's set on line 9. Now this is a little bit of a joke and an attempt to make sure that Kubernetes can never execute this periodically. I have it set to February 30th, a date which doesn't exist. The next thing that I always make sure that I set is the restart policy. That's shown here on line 17. The default restart policy in Kubernetes is always, and that means that Kubernetes is going to restart your pod every time it exits. This is ideal if you're running something like a web service, an API. When you are running something like a task, you want it to complete and then shut down and not just keep restarting. So I always set mine to on failure. This means that if a container in this pod were to fail, then the entire pod is restarted. But if everything exits successfully, Kubernetes just marks the pod as complete. So with the suspend and the restart policy covered, let's get into how the pods actually work. The first thing we do is set up a volume. This is going to be a shared volume that each container in the pod can access. This is how I pass data between each step. The bulk of the steps go in the init containers section. Init containers, if you don't know, they always run first and they always run in order. That means they're never running at the same time, so you can guarantee that the steps defined in step 1 are going to happen before step 2, and that before step 3, so on and so forth. In this example, step 1, my step 1 init container is to get the data that I care about and store that in that shared volume that we created above. Step 2 is usually going to be to process that data in some way, perhaps decompress an archive. You may modify the data before you import it into another database. And then step 3, this is where I'm going to do something with that data. For example, you could import it into a different database server or upload the modified data from step 2 into object storage. Now, once all 3 of these steps complete in order, then what I call the finisher container executes. Now, every pod in Kubernetes has to have at least one object under the containers key. You call this an app container. This is where I will do cleanup if I need to delete any of my local files, depending on the type of volume that I used. Or I may send notifications to my team. For example, send a message to a Slack channel saying, hey, the nightly tasks are complete. That's pretty much it. It's a pretty basic system using just regular Kubernetes cron job objects. You don't have to have any special operators. You don't need a big, DevOps or GitOps workflow platform installed on your cluster. This is going to work out of the box. And anything that you would have done on a standard Linux server, you could do this way. Next, we're going to jump into applying this to a Kubernetes cluster and showing how this cron job can be used as a template for future tasks. So the first thing that we want to do is turn off caps lock. We're going to apply the YAML that you see on the left-hand side of your screen. We're going to apply that to the Kubernetes cluster. That cron job has been created. Let's take a look at it. So you can see here, this is the one that we just created. If you look at this suspend column, the third column here, you see that it's set to true. That means that it's not going to be executed by accident or by schedule. Now, if you want to use this cron job as a template, all you need to do is you'll create a job from this cron job. So you're just going to say kubectl create job from CJ is short for cron job, the name of the cron job that you've just created, and I'm going to call this one manual run 1. So Kubernetes has created this job for us, and underneath that job it's created a pod. Now, if you look at the third column of this pod output, it's the status, and what it's telling you is which step in the process is Kubernetes executing. So, as you can see, it is just moving through, and it's executing those 3 init containers. So it's still on the second one. Should move to the third one and maybe now. And it's finally, it did run the finisher. Now that exited so quick you didn't see it, but we can still take a look at the logs here, and we can actually look at the logs for each step. So first, let's take a look at step 1. So there is the output of step 1 right there. You can see it on the left-hand side of your screen. Step 2, again on the left-hand side of your screen, I've got that code highlighted. And look at step 3. Over here on the left, that code is highlighted. And then finally, Kubernetes executed the app containers. Now, the finisher, because it is the app container, it's the only one, you don't need to provide any container name to the kubectl logs command. So this is a good place to just give a brief overview of what happened. So success, there was nothing to report. Again, in production, I do use this to send notifications where appropriate. That pretty much covers this. If you found this helpful, please give a thumbs up, like our video, subscribe if you'd like to see more. In the next video, I will extend this to include Kubernetes RBAC, so that's Kubernetes permissions, that role-based access control, and webhooks, and I'll show you how to bring this all together to expose functions outside of your Kubernetes cluster to things like GitHub Actions or Slack bots. Thank you.